Suggest your integration problems in the comment section below and I will use it in my next integration problem video content. Hello guys, my name is Bob. Welcome to the Excel Math channel. In this video, I'm going to work out some basic integration problems in 2019. Woo! Alright, previous basic integration problems video has been pretty much popular with me showing some of the work problems, and people are asking, hey, do you have any other more problems so that I can work out together with you? So here we go. We have another video on the basic integration problems. So let's just start off with this problem. All right, so for the first question is I want to integrate 12, which is a constant with respect to y. So this is actually a indefinite integral. All right, so we want to work out this. So the answer of integrating a constant is just basically putting a unknown, beside the constant. So it's, for this case, integration of 12 dy is equals to 12y plus c. So note that every time when we integrate or when we do a indefinite integral, we always have to put a plus c behind. All right, simple and straightforward. The next question, we have integration of z8 minus 6z to the power 5 plus 4z to the power 3 minus 2 divided by z to the power 4. And then we have to integrate with respect to, integrate with respect to z. So what do we do now first when you see this kind of question? Okay, the first thing that I will do is to divide, all these terms on top. So how do I do it? I separate into 4 different terms. So this is actually equivalent to the integration of z to the power of 8 divided by z to the power of 4 minus 6z to the power of 5 divided by z to the power of 4 plus 4z to the power of 3 over z to the power of 4 minus 2 over z to the power of 4. And don't forget to put a bracket behind, okay? The whole thing itself, we have to integrate, all right? Okay, so this, all right, is equivalent to, let's just work out, the division in each individual term. So for the first term, what you get is z to the power of 8 divided by z to the power of 4 is z to the power of 4 minus away. The second term, 6z to the power of 5 minus z to the power of 4, you can actually cancel and you're left with z. So it's 6z plus, so it's 4 times z to the power of 3 divided by z to the power of 4. You cancel and you're left with 4 over z minus away. Well, this is just basically 2 over z to the power of 4 dx. All right. And then the next thing, following which I will do, I will bring, up this z into the numerator. How do I do it? It's just basically convert it into a indices, all right? So for the first 2 terms itself, it will be the same. And then the third term itself, if you were to bring this z up to the numerator, you actually get z to the power of negative 1. All right, so z to the power of negative 1 is the same as 1 over z. Minus 2, if I bring this z to the power of 4 up to the numerator, that would be z to the power of negative 4. All right, the reason why I do this is that it's easier to work this way. It's easier to work the integration in this way. And last but not least, what I will do is that I will work out the integration, all right, using, separated term by terms. So this whole chunk is actually equivalent to integrating the individual terms itself. So let's start with the first term. When we integrate, z to the power of 4 is the same as we add 1 to the power, so that's 4 plus 1 to the power. At the same time, we divide by the power itself, so it's 4 plus 1. Subtract the second term is 6z to the power of 1 plus 1. This is just means that it's z to the power of 1 divided by 1 plus 1 plus How about this? This is pretty much interesting, okay? So this is a little bit different because when you integrate 1 over z, so you get back ln. So it's actually plus 4 ln z, right? And the z itself is in absolute form. Minus away, for the last term itself, it's 2z to the power of negative 4 plus 1 over negative 4 plus 1. And of course, every time we do a indefinite integral, we have to put a plus c behind. Okay, so which means the first term itself is just z to the power 5 over 5. The second term is 6 times z to the power of 2 over 2 plus 4 ln absolute z minus away 2z to the power of negative 3 over minus 3, all right, plus c. We just kind of like can adjust this third term itself, so this will becomes plus and then this will be gone, and that will be the final answer, right? Or if you want to look a little bit lines, you can actually bring the z down into the denominator, so it doesn't really matter in this case. Okay, so and finally, the last but not least, we work out this problem whereby we want to find out the integration of square root of x to the power 7 plus cube root of x to the power 5, this whole thing dx, all right? How do we work this out? We work this out in this manner. First thing first, we convert all the sets into the indices, so that will be x to the power 7 divided by 2, because it's square root. Square root means half, to the power of half, right? So in the end, you'll get this, x to the power 7 over 2, plus, for this term itself, it's x to the power of 5 over 3, because cube root of x is just basically equivalent to x to the power of 1/3, all right? And this whole chunk is dx, and then you straight away can do the integration. So when you do the integration itself, you will get x to the power of 7 over 2 plus 1 divided by 7 over 2 plus 1 plus x to the power of 5 over 3 plus 1 and divided by 5 over 3 plus 1. Then you can simplify this solution and then you'll get your final answer. So here you go. This is the basic integration problems in 2019. All right, so if you guys have any comments for this video, do comment in the comment section below, and thank you guys for watching, and I hope this helps in you to understand how to do some basic integrations of your math problems. Thank you guys.